You're watching the Intel Network and Edge V-Summit series with our focus today on 5G. Verizon is leading the transformation of the 5G RAN to enable the rapid delivery of new services and use cases. The CSP is adopting a virtual RAN approach to support this delivery of innovative and rich experiences to users via the radio access network and edge computing. Joining me now to explain more is Shankar Venkatraman, Technical Fellow RAN Planning at Verizon. Shankar, very good to meet you. Thanks for joining us on the program.
Hi, thank you for having me.
Shankar, how has the RAN evolved over the years and what trends are we seeing today?
So when I guess all of cellular communication, started getting deployed with the first and second generation of cellular technology, it was largely focused on cellular voice and providing coverage. Obviously, with 3G and 4G, what networks have enabled is wireless data, and that's really ushered in the era of applications. And more recently, even Internet of Things, even on our 4G network. I think now we are rapidly going towards 5G. Verizon has already launched 5G networks in the United States, and that brings in a set of really new requirements and new drivers. We see primarily the need for supporting a wide variety of services, very low latency, but also very high bandwidth. There's a need for supporting completely new use cases with services like edge computing. That's also applicable to the enterprise environment. And last but not least, the ever-growing demand for data still needs to be addressed in a highly efficient way. These are, some of the key changes we see happening, and that really forces us to think about how we build networks.
And why has Verizon chosen to adopt the virtual RAN implementation, and how exactly are you going to be implementing it?
Well, Verizon has been at the forefront of virtualizing networks. We started with the core networks, and we are now actually advancing towards the radio access network. Like I said earlier, there is a need to rethink the way we build networks to essentially address all of the challenges and use cases coming upon us. And we really need to do it in a very, very agile fashion. So virtualization for the RAN kind of enables us to take steps in that direction. In the radio access network itself, we started with virtualizing the higher layers of the radio access network, primarily the radio resource management, and all of the intelligence in that were virtualized. And we have already deployed that, and we call it vRAN 1.0. And now we're working hard and trying to advance with our partners virtualization of all of the lower layers of the baseband processing. We call it vRAN 2.0. And that would allow us to deploy highly flexible networks that can cater to not just today's needs, but tomorrow's needs.
And by adopting this virtual RAN approach, what benefits do you expect to see?
I think virtualized RAN brings inherently several benefits to address the key 5G needs. It provides us infrastructure that is highly flexible. And what that does is it allows us to essentially build the networks on best performing software. It provides us a vehicle to introduce innovation on the software side through upgrades. And that again allows us to be far more agile in deploying and catering to new services. And furthermore, what the flexibility helps us with is in the ability to utilize network infrastructure resources in a much more efficient way. We are able to allocate resources to needs on a per site basis, and have the ability to pool resources more efficiently than we have ever done before. Beyond that, the virtualized infrastructure used for RAN now becomes common in the way we manage it with what's happening on the core. This is very important for the operator because now we have a single set of tooling as well as a single similar competencies as we try to evolve to a virtualized world. And manageability is a very, very important aspect for the operator. Last but not least, this will be the vehicle to enable easier introduction of edge compute and edge services, which is certainly a key driver and a key need in the 5G world.
Well, let me follow up on that last point you made. How does this virtualized infrastructure support the deployment of edge computing services?
Yes. So edge computing services themselves can come in many different flavors. And there is a lot more there that will become clear in the upcoming years. However, I think what is true is that as we build radio access networks, in order to support these edge services, there are a few key requirements. There is a need for us to locally offload data and present data to these edge applications. And that requires the ability to spin up local gateways and local user plane handling. And this is something that can easily utilize existing general purpose compute infrastructure. And that is a very easy way wherein we now have the flexibility to repurpose infrastructure to aid any MEC application that could be co-located.
And what are the industry challenges that you're seeing during the design phase of the 5G vRAN?
Yeah, I think it must be said that we are in this initial stage of virtualizing the RAN. There are challenges as we work through all of the implementation aspects. The need for flexible infrastructure is there, but at the same time, the infrastructure has to fit into the same deployment constraints as earlier, meaning it has to fit into similar form factors, similar power and space, and in fact, or even do better. And it has to serve the similar reliability goals as earlier. So I think what we see as an industry is the IT world is now working towards meeting all of those needs. And we think that will accelerate even more over the upcoming years. But these are some of the things that we had to work through to get to this point in time. That's on the infrastructure piece itself. Then there are other challenges that as an industry we have to work through, because as a traditional operator, in the past, we largely deployed single vendor solutions that were highly integrated vertically. The new model requires us to essentially source from multiple vendors, collaborate as a team more, and partner up and basically integrate. And we have been on that journey for a while, and we're just taking that to the next level and using automation to solve some of those deployment challenges. Last but not least, infrastructure security becomes more important in general, and certainly important in the virtualized world.
Now, collaboration is always so important, especially so for vRAN. Can you tell us more about how you're working with Intel and your other partners?
Yes, indeed. Like I said earlier, collaboration is critical at this point in time as we all try to change the way we deploy networks. And we have very close working partnerships um, with Intel, with the various different uh, server suppliers and infrastructure suppliers, but also with the RAN software developers. I think um, we have very close partnership in uh, finding the best uh, silicon choices, creating the best um, set of uh, components that actually drive efficiency, and to ensure that software developers can basically optimize their software to leverage uh, the best techniques and the best methods that can, yield the best efficiency in an end product. So all of these areas do require immense amount of collaboration, and happy to see that that's already ongoing.
Shankar, great insights. Thank you very much indeed for joining us on the programme. And don't forget, you can watch additional interviews and discussions on 5G as part of the Intel Network and Edge V Summit series. But for now, thank you for watching and goodbye.